Let us consider two mirrors inclined at an angle of 120 degrees. Whenever we have such mirrors given, it is important to extend them and draw the extended mirrors. Why? Because objects do get reflected from extended mirrors as well. For instance, let us say this is a mirror. Let us say I am drawing a mirror over here. Let us say an object is not placed directly in front of the mirror. Let us say that an object, right now it is placed in front of the mirror, but let's say it's not placed directly in front of the mirror. Let us say the object is placed over here. Now, it stands to reason that even for this object, this particular mirror will form a reflection. So the rays that will come from the object will get reflected from the mirror. An image of the object will be formed. We are also going to study this concept separately. This concept is called as the concept of field of view. Meaning, let us say this is an object. Let me draw a point object. Let us say this is a point object, let us say. Even though this point object is not directly placed in front of the mirror. So this is the region in front of the mirror. The point object was not directly placed in front of the mirror. Still, we are going to get the image of this point object in this particular mirror. Because rays that will arrive from this point object will get reflected from the mirror according to the laws of reflection, like so. And this particular region is the region from which this particular point object can be viewed. This region can be said to be the field of view of this object with respect to this mirror. In conclusion, what we can say is that an object that is not placed directly in front of the mirror, like this object over here, can still form an image in the mirror. But let us see what happens to an object that is placed behind the mirror. Let us say if the object is placed behind the mirror, so this is the mirror, and if let us say the object is placed anywhere behind the mirror, then in that case, the object will not form an image. The reflecting surface of the mirror is towards the right hand side in this particular diagram. So the object that is placed behind the mirror, like over here, okay, these particular objects will not form any image because the rays of light that will emanate from the object will not go and hit the mirror. The rays will not bend like this and go and hit the mirror's reflecting surface and get reflected. That's not possible. Alright, so now let's understand the reason why we have drawn this extended line segments in order to represent these two mirrors. It is because the object will still get reflected even if it is not directly placed in front of the mirror, and so will its images. Basically, let's see what we mean. Let us say we have an object that is placed at plus 25 degrees. Alright, also note the sign convention that if we are going compared to this zero angle, this angle is 0 right over here, which is like the x-axis. If we are going anti-clockwise, then we consider the angle to be positive, and if we are going clockwise, then we consider the angle to be negative. Okay, so now this particular object right over here, which is placed at plus 25, will get reflected for the first time over here at minus 25. Alright, let me draw the region that represents the region behind both the mirrors. So this particular region right over here represents the region that lies behind both the mirrors. So once the object gets reflected and comes into this particular region, then there will be no further reflection. Alright, so this first image, okay, let me label this image as I1. So this first image that has formulated, this first image will now get reflected in this particular extended mirror. Let me also name the mirrors. Let us say this mirror is called as M alpha and this mirror is called as M beta. So the first image, since it is reflected from M alpha, we can label it as I1 alpha. Alright. Now this I1 is going to be reflected from this extended mirror M beta. When it gets reflected, we can intuitively understand that it will go somewhere over here after reflection from the extended mirror M beta. Alright, now if it is going to move over here, let's calculate exactly where it will reach. This angle is 25 degree in magnitude. This angle is 60 degrees in magnitude. If I were to draw it over here, this is 60 degrees in magnitude. This particular point we label as minus 60. Alright, so what is the angular distance of this image I1 alpha from this mirror M beta? It is nothing but 35 degrees. This is the angular separation in magnitude. So furthermore, the image is going to be formulated at 35 degrees ahead of this particular point. That means the next image, which I choose to name as I2, and since this got reflected from the extended mirror M beta, I choose to name this image as I2 beta. So this image is at an angular distance of 25, 35 and 35. So that means 95, or you can measure it as 60 plus 35, which is 95. And since we are going clockwise, we are considering this point to be minus 95. So if I have to write down the angle according to our convention, I have to write down minus 95 right over here. Alright, so this is the image, and since now we have reached behind both the mirrors, we have reached the region that happens to be behind both the mirrors, no further reflection will happen apart from this. Alright, now let us consider the reflection that happens from this plus 25 directly onto the mirror M beta. So firstly here the first reflection happened on M alpha and then the second reflection happened on M beta. Now let's consider the reflection that happens directly on M beta. For that we'll have to note the angular separation of the object with respect to the mirror M beta. So this angular separation, how much does it happen to be? It happens to be 95. Alright, because 120 minus this is 25. So 120 minus 25 gives us 95. So furthermore, the image is going to be formed at 95 ahead of this mirror. We are simply using the laws of reflection. So 95 degrees ahead of the mirror M beta, the image will be formed. So that means the image will be formed at 120 plus 95, that is 215. Now 215, let us say this is the image over here. I'll note this image in white color. Let us say this is the image over here. This image is at 215 degrees. Now if we were to measure the same from this end, let's say we are to measure this point from this end like so, then this particular angle will be considered as, so this is 180 degrees and this is 35 ahead of 180 degrees. So this is 35 ahead of 180 degrees. That means this particular angle will be 180 minus 35, which is 145. So we'll have to represent this as minus 145 degrees. Okay, and this image I will name as I3, and since it got reflected from the mirror beta, I'll label it as I3 beta. So what is the total number of images formed in this particular case? Let's analyze. So this is the first image which is formed at minus 25. There is this second image formed at minus 95, and there is this third image which is formed at minus 145. Since the concept of measuring angles involves circular symmetry, because of that any particular angle can be represented in many particular ways. Like for example, this particular angle can also be represented as plus 215 degrees, or it could be represented as minus 145 degrees. So total 3 images will be formed of this particular object, that is a point object kept at plus 25 degrees with respect to the x-axis.